Mm-hmm. Da, 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 da. Red square. See if that embeds properly. It entirely might not embed properly. Totally, I mean, it's there, it's just not embedding. That's interesting. Announcements. Stream notifications, because it looks like it's fine. I don't have to edit it for anything. Stream notifications. Viewer, that's a different one. Boom. Locally. Get that out of the way. Get this over here. But dude, maybe I should have enabled streamer goddamn mode. Back to my settings. I usually just disable streamer mode. But if I'm gonna get pings, where the heck is streamer mode? Turn it on for now. There we go. Now. Okay. Here so I can see stuff. Alright. What do I need to figure out here? So, Del S, no, not Del, RMDir SQ. So we're at the point right now. So let's say CLS this, and node, and bin Cinder, and just see what happens. Syntax of the command is incorrect. Was it the CLS? Do I have to do and for CLS? Interesting. Okay. So we have to fix that issue. I want to look this up. So in a nice old fancy old new tab here, the procedure entry point question 3 at Yax peaks k at z could not be located in the dynamic link library. Yeah, that's not a very technical answer. So this is probably, I was trying to access something. So I need to explicitly link with some libc something. Hold on. Okay, so if I just say okay, and we say clang o, let me go back to the rm bin. If I then say clang o bin cinder exe, and then we just say like star cinder star dot c. I don't actually know if this is going to work at the shell level. Yeah, no, it doesn't like that. So I guess I could just use knob to try to do that and see if it works without. Because here's the problem, right? We're not linking against I wonder if it's the PDB file. But no, because I removed the PDB. I removed the DLL. Okay, let's copy this command, but we don't want it to be shared, and we don't want it to generate a DLL. We want it to generate the exe like this. Oh. If it does that, entry point must be defined, right? Because now we need to... Oh, is that why? Because I just forgot to provide the fucking main file. So if I add cinder c, is that literally all I forgot when generating the executable? But I shouldn't have, right? Clang? Oh, well, for the DLL portion, yeah. So for generating the, I guess I can just do that on Windows if something's wrong. But I want to make it work with the libraries, because why is it breaking with the libraries? So, oh, that's not what I wanted at all. Forward. Give me my dashboard. Give me my stuff back. Pause. Okay. Procedure, enter point, whatever. Okay, so it's just clearly not happy. Doesn't matter. I can't just like LC. That wouldn't change anything. Not open c.lib yet. So it doesn't like that. WL genuinely, I wonder what it's missing. Okay, hold on. Let's just remove this. Let me go. I don't have another tab. Let me make it. I don't know. Is it just Control T in here as well? No, Control T doesn't do anything. Alt click to just okay, whatever. So then that still works. Cool. Let's go back to my thing and cd. So like, is my Windows development just fucked? Include stdio.h error hello test claim test exe test c test. Okay, so there's nothing wrong with just building this. So what? Is that a thing? File is not a thing. So what the hell is going on here? Can I just... Okay, can we remove GDB and sanitize address? And this. Make dir. Do it again. Cinder. That's literally it. So on Windows, I have a broken... Is it just GDB? I think it might just be GDB. That might be the problem. No, it's sanitize address. Sanitize address. Okay, so that's all that is. Then bin cinder example Cinder. Oh, right, because I have to fucking rebuild it now. So we decided GGDB was fine. Still works. Okay, so micro knob C. So if we're on Windows, let me go ahead and factor a couple of things out here and say define C flags command to be knob command append command. And we're going to grab a bunch from here. Right. So this is going to be include Cinder. Then we want, let me just do this. Boop-a-da-doop-doop. So we can just, all of this is fine. Do this. 0. So then we'll just put this on this line. Indent all of this. Put that there. Do that. So then everywhere that I've got this now, I also need to go. So there's our C flags. You couldn't copy paste? Oh, because it was from outside of. Okay. Now. Let's see. So on this one, we don't need CRT secure no warnings. On this one, we're going to develop with sanitize rest. So then next, we want LD flags. So then for LD flags, we don't need the define anymore. I'm going to keep GGDB. We don't need anything else. It's just going to be GGDB. Each of these needs a backslash. Then here, C flags and LD flags. So then here, basically same thing. Keep GGDB, but also have sanitizes address. Okay, so then we're building an object here. I think I'm going to remove the Cinder include on all of these and keep it explicitly here. So then this is going to be C flags command. Right. Then building a dynamic library. These are all going to be C flags. Oh, right. Gotta remember I can't do that in this. C flags. But also LD flags, right? Like, no, not LD flags. Then for building the executable, LD flags. That. Okay. Now, what? Well, we don't like that. So this first one, C flags was fine. Yeah, but here, LD flags down here. render sq bin. Run knob again. Okay. Bin cinder. Okay. So something else to include here is LD flags should probably include WL logo. Remove it, do it again. Oh. Right, because lib needs a logo as well. That's what I missed. Okay, so then I'm doing my lib call down here. Build object, build library. No logo. Right, that's easy. I hate the history here. Do this. All of that. So now we've got example Cinder. Okay. So if I go back into Cinder lib frontend Lexer and go to the very bottom. So now I can say knob, so CLS and knob and that. Right. Because now I need to bring back. Okay, so there's all my tokens. That's incredible. Micro this, remove std.io, remove this. Okay, actually, if I come back here and then come back here and go to Cinder and then say CLS and knob and bin Cinder exe example Cinder. Very interesting. Oh, and I realize a lot of my errors are going to go way off the screen, but that's fine. I should probably fill up my water. Make sure everything's up to date. Yeah, cool. Water, maybe. Wake up my cat. Oh, wait a minute. So that might actually be fine. Might be able to go back into my Linux. Git stats. Yeah. Git add. Git commit. Get Windows build working for you. Git push. Hopefully this LFSs correctly. Guess I should have checked that. If I come back over here and open Git attributes, no. Lib maybe would have worked. Git LFS add under I don't have Git LFS on here. Get we'll see, we'll see. Can we I think I have LFS. Because LFS isn't going to work there. Releases, that's what I want. Why does my foot itch? Just do the Windows installer. So worry about whatever's going on here. Okay, so meow. Yeah, baby girl. What are you looking for? Yeah, you were just napping. What is that? What do you need? Yeah, you might be hungry. Do you need food? Can I see you? You need food? Let's go food. While this is uploading, let's go food. Get up. Yeah, that's fair. Okay. Do I have my tug? I don't think I have an upstream though, so it's not going to do anything. It's fine. Get config alias tug. Get fetch and get rebase. That's what tug does. Interesting. Let me go try that on. Okay, get config alias tug. Get fetch get rebase. Oh, right. What the fuck? Get fetch. Get. See, this didn't have the bang though. See, what's going on there? What am I doing there? Okay, where the fuck is my config? What? Well, that's why. Clean smudge process. Tug. where the fuck is global? Git config is so this adds. We don't want anything in objects, so micro git ignore. Git random cache findings, git path findings. Oh. So that should just add CS is pressed. Sure. I don't actually even know if all that was on screen. I think the right edge is still fine being off screen. So. Okay. Put you over here instead. Yeah, you could see enough of it, that's fine. Git Doug. Cool. Why does it keep ending up over here? I don't want that. I want this over here. There. Let me subject case. Go to my channel. Why is it set to private? Public. Got it. All right, let's just stop streaming. What about now? If that's the wrong one. That'll take me to the old stream, right? This link. That's the same video link. So is it public? Okay, now it works, apparently. Okay, get that up and ready, get this over here. I think I'm honestly done on Windows already. It took me 30 minutes to get things going, but we're gonna probably quickly get back to the Linux box. Kill both of those, okay. So then, if I just zoom in, that does the whole thing. Increase. I don't know what that's bound to. Okay, well. Okay, that's close enough. Okie dokie. Okie dokie. Now I can move this somewhere that's a little bit more useful to me. Okie dokie. Just in case. Cool. Go back to my example. Cool, everything's still working. Hopefully this will build on any old Windows install right now. Builds on my current one, but it's a little bit janky sometimes. And it doesn't work with MSVC on its own yet, technically, so that'll be a whole separate problem to solve. Sure. Okay. So, I could do a couple things here. I've got this version that can be updated somewhere. I've also got if I go into driver.c, in here, I think I want to say if not defined, Cinder git hash, and if then define Cinder. If I go into here, this is saying Cinder compiler version. That's fine. Cinder driver version to be a Cinder compiler version plus git. If I claim version, it formats that as it just says git. Which is fine. And then it also suffixes it with the git hash, Cinder git hash. I'll just put this at https://codebird.org cinder space git hash. Right. Else define Cinder driver version as Cinder compiler version, just straight up. So then, when we're doing anything that prints the version, right? So let's say, hey, when we get the args here, if options print version, printf stood error, actually stood out is fine. We want to say Cinder this. And why is it not happy about this? Because git hash should be, I was going to define it as something else, that's why. You see, stop. Don't eat that. Don't eat that, baby girl. Come here. Yeah, do this. There you go. You can eat that instead. That's good. So now I'm live on the channel, thanks. Now we want to get this get hash in there from knob. So whenever we're building, so let's say like static const car get hash, sure. So return hash and then fail can return null pointer. Constant hash, which could also be a failure condition, I guess. So that's fine. So we want to say knob command append get. I forget what it is. If I say get rev parse or something, there's something. Get latest commit hash. Rev parse verify. Rev parse just regular head, not whatever I did here. So that's that. If I say short, that's that. So let's do the full rev parse and say get rev parse head. Then we want to try knob command run the command with stood out path equal to get rev oh, I need to pause this. Let's go ahead and think my get rev get hash dot text that. Then I think in all cases here instead we're just going to say if this, then we're gonna say knob read entire file get hash text into a string builder, knob string builder sb, right, into the string builder. Then knob ga append sb. Do I have a knob sb append null? Actually, there we go. Sb, that's what I want. Then hash is sb items, and remove get hash text like that. Right? If not this, return null pointer. That's fine. So then, whenever we're building an object or anything else, so let's say static const car hash. If hash not equal to null pointer, return hash. Right. That's fun. So then, up here in C flags, then we can also just say let's just do this and say knob temp sprintf d cinder get hash equals get hash. And I think doing this in both is what we want. So, because null pointer is not a thing. So what if I do not that? Missing terminating quote. Ha! Why is it not defining the ending quote? Because there's a fucking new line at the end. That's why. SB count minus. There we go. So then if I say bin Cinder version, cool. So this doesn't put like that. That's fine. I think I like that format better. So if I come over here, this Cinder version, do that. Then my version.h doesn't need the v because that doesn't make sense anyway. So now, just include that. We get the version. 010 get, cool. So we're working now on some of these driver options, getting the parser and a compilation working. So if I split right and grab compilation, this is what I want to start building out. Is like this whole compilation builder thing. So after we get here, we're going to say auto compilation. Because we're going to assume for right now that it's a single compilation, and then we'll start building out multi-compilation stuff, and that's how we're going to like multi-process the compiler, is this compilation thing. So auto compilation, I'll just call it CC. That's so much easier to type, is Cinder compilation create, and it needs driver allocator. Okay, so then we can Cinder compilation destroy the compilation. CC for Cinder compilation. See, wow. So before we do anything else, let's sure. Now I can say fail. Just return. In this case, I do kind of want the defer macro to return the status. And int status can be 0. So I don't have a return defer anymore, I don't think. I think we got rid of return defer. Let's find out. Return, I do still have a return defer. That is great. We'd love to see it. So there's our compilation. Destroy the compilation. Now, what we're going to do is say for each input file here, that's going to be options input file count. For every input file, if it's a Cinder source, so let's say auto input file is this input file. Don't want to copy that anymore. Then we want to say Cinder compilation add source from file. Now I haven't given it the thing, that's fine. So this is going to take CC, and it's going to take also input file path. So all of these need to take this. So then get source count. Take this, get source. Oh, that one already did. These already did do that. Okay, that's fine. Compilation. Okay. So now we've added a source from file, and we don't care about the source ID in this case. We're just going to add a shit ton, I think, because we can query them whenever. And most of this is going to happen inside the compilation anyway. So now we've added all the source files. Then somewhere down here, Cinder compilation run. That's the kind of thing we want to do. Now, Cinder compilation run should probably return some status of what happened in the compilation. So let's type def Cinder compilation results. Cinder compilation success. Oh, that's 0. So then we can just say, hey, run is going to return this result. So then we can say status equals cast it into that, which is fine by me. So. We don't have a way yet to specify anything specific, but that's fine. So let's go into I don't have a compilation.c yet. I don't. So let's go create in driver compilation. So in driver compilation.c. Include Cinder driver compilation.h. I just don't like typing that word. That might be one I try to autocomplete more often. Okay, so compile C. We need these 3 things first, plus this thing separately. So here. Auto CC. I'm gonna, everywhere that I do compilation like this, I am just gonna start calling it CC. Because, wow, I hate typing that. So many buzzes. Give me just a second to know that there's no. Delete, 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 delete. Call me Mikami the way I'm deleting all these messages. So we want to Cinder typed alloc allocator and Cinder compilation return cc. So why doesn't it like? Because I have to create it. Type struct Cinder compilation. Now we have Cinder allocator. Now we want a dynamic array of a lot of things. So type def, no, let me Cinder type, Cinder dynamic array type of Cinder sources. I should have actually, do I have Cinder sources? No. I have source ID. It's so weird that it's picking up on things. It's typo fixing for me and still taking me to the thing. So I'm gonna grab this and say this is Cinder source IDs, which should still take me here, which is crazy. Include Cinder core dynamic array. Source IDs for Cinder source ID, like that. Okay. So that's one. Now we have all of the Cinder sources. Cinder compilation and source from file. Now, yes, we need to know what kind of compilation in the future when we get to C stuff, but that's fine for now. So CC is, CC, can I do that? Type of star CC, there we go. That's always fun. Allocator. Then we don't have much else yet. So Cinder destroy. Hands are all over the place today. I don't like that. If CC is null pointer, auto allocator is CC allocator Cinder dealloc allocators C. That's fine. For right now, that's all we gotta do. So in order to run the compilation, return Cinder compilation success. Ow. And here, this is where I can say compilation should probably be what has its own diagnostics and stuff, question mark. Okay, API things. Should this accept a source manager? I think, okay, hold on. Driver H. This accepts nothing, but it creates its own source manager. And the diagnostics engine needs a source manager, that's why. So, sorry, thinking through API stuff in my head. We create a driver. The driver creates compilations. Maybe this just means that instead of taking in an allocator, this takes in a driver. Like that. So problem now is these are going to have to go back and forth. So let's go into driver types and just say if Cinder driver types if include let's just say type def struct Cinder driver type def struct Cinder compilation like that. Then we don't have to redefine this. We don't have to go driver.h doesn't have to do this. Meow. Yeah, what do you need? I don't know what that means, but you got my attention. You can't just come and yell at me and expect me to know what you mean. We gotta figure out how to communicate. Oh, hi there. Is that all you want is attention, or are you just gonna sit here and look pretty? So back in lib, let's do driver h here. So if in def Cinder impl driver h, fine. Have you seen that? I need you to not push all my buttons, please. That would be mighty convenient of you to not do, you know. I have no idea what you just did. So, you went to definition? I don't know. Include Cinder front end types. Not front end, we want driver. We've seen a don't. Oh, you hit insert. That's part of what you did. Driver types. Driver. And you know what? For shits and giggles, compilation. I'm going to need it. Now, from driver.c, we can grab. I'm not sure. We'll put all of this in driver.h because it's kind of not the end of the world. So here we have this. So now when we go into driver.c, I want to include driver.h. And also, can you get off my mouse, baby girl? I need that. Now, the compilation instead of taking this, takes a Cinder driver. So every compilation is in the context of a driver. Now, driver, if driver is null pointer, return null pointer. That's easy. Auto allocator is driver allocator. Now we have this. So then, also in here, we want Cinder diagnostic engine, diags, Cinder source manager, which we can just copy at a driver. Diags, dot source manager, driver source manager. Both. In the short term, we're lowering to LLVMIR, and I'm not planning to remove support for that for a while because it's just a good compiler backend. That'll shortcut me getting things done. And then I want to have a few different backends, ideally. A C backend would be good just for portability and to really stress test things, because C can be finicky and it'll make sure my code gen is good. I'd like to have my own assembler backends eventually, but I'm not really planning to make those first. I'd like to have my own IR eventually, but every time I try to do that, I get way too carried away, so we're just not going to do that anytime soon. Executive decision not to do that. Yeah, I want a simple one eventually, but every time I think about it, I way overcomplicate it, and it's just a pain. So there's our compilation. We don't have to do anything different right now. So here, now we can say just auto source is if cc is null pointer, return 0, that's fine. Source is cc source manager, Cinder source manager, Cinder source from question mark. Here, read from file. So this is where we grab our source manager. Source manager. The diagnostics engine comes from cc diags. And here we need is it just going to include it? In the wrong spot, yes, but there. Okay, so return source is fine. What we want to do here then is, I don't think this interns its own, does it? Name. It does copy the name. Okay, so then what I'm going to do here is car name temp is going to be file path count, and then copy into name temp file name items file path, and then file path count, not items, and this one's data, and name temp why does I need to include stdlib and string idor, then name temp 0, not 0, is 0, so I don't have to do any allocation in one place or another. This will just get freed, name temp like that. I'm not doing anything with it yet, so we need to Cinder dinar push cc source and then return it. Okay, so that gives us things we can do. Now running is a whole different story, so let's go back to driver. And the only thing we're doing right now for running is creating a lexer, running the lexer on things, and then deinitializing the lexer. So let's just cut this and go back to the compilation, just paste it into run, and start fucking with it. So this will be defer. So Cinder lexer, we need to include front end. This one, front end lexer gets us those. So now we can do things here, and this is cc allocator, cc diags, cc source manager. So then our source file count is now cc Cinder sources count times I, and then yeah, at this point we have an array of token things. Do I leave that on the stack here? I think so. So if I say Cinder token source tokens sub this, we'll find more sophisticated, correct ways to do this later. This will just make our lives easy. So now if I do this, nothing will change off the rip. We have leaked. Okay, because we need to, when destroying now, Cinder dynamic array deinitialize cc sources, and that will fix that. Cool. So now we've got the high-level concept of a compilation, which we can use to start constructing like various compiler calls. That should be yes, baby. Don't put your head on my keyboard though, please. Thank you, sweet girl. I'm not leaving. You can take a nap. Kitty cat. Almost on my keyboard, cat. So version git hash central concept compilation. So I forgot to make a commit separating those two. That's fine. I don't want to mess with it. Then we need to move on to either doing more things in the so I've got three options here. Continue doing more sophisticated option parsing, which I don't really have a reason to do yet because there's not a whole lot of things to control. Finish more things in the lexer, which is also not necessary right now, strictly speaking. And start the parser is an option, basically. At least scaffolding up a parser sounds like fun. So let's go to the front end. Start up here. Front end needs parser.h. If and def Cinder front end parser. Define that. Include Cinder core compiler. Include Cinder core. Okay, so not core. Front end. Do we have tokens separate? I think it's all just in the lexer, which sucks. Cinder front end lexer. Oh, it's in syntax. That's right. Okay, syntax. Because now syntax has. Why can't you go? Does it have to be in here? Do I have to click on the right spot? What the hell is that? Oh, if and def. What the heck? Double what the heck? That's why. This is a shit question, but when you write lexers, do you typically have the parser call the lexer to get tokens, or do you have the lexer read the entire file? I do either or, whichever feels right. For this one, we're reading all the tokens at once because I don't have a strong reason not to. When I was doing a really complicated project where it made more sense to have. I think in almost every case I've made it not necessary So, okay, so here's the real thing. Do you care about the storage requirement of having an array of tokens? If you only ever want to care about a single token at a time with like a minimal buffer of look ahead, and you don't really want to just read the whole file ahead at once because memory reasons, you can have a small look ahead buffer in your parser. Then you're tying the running of your lexer to the running of your parser, and that's fine. I, for the time being, am just saying it's less complicated from an API perspective to just have an array of tokens be the output. That means I'm consuming more memory and potentially reallocating a dynamic array multiple times, so that might be removed in the future, but I just didn't want to design an API that had to have a re-enterable lexer, basically. So the API I've got for my lexer right now, to keep it simple, is just you create a lexer that can be reused multiple times, and you lex all the tokens at once. If I wanted to have a re-enterable lexer, I'd have to have Cinder API like void Cinder lexer begin on Cinder lexer, and then take a Cinder source ID source, and then you have to like do a begin and end, or just have a single lexer instance for the source and then dispose of it each time. So then this would be end, and I'd pass in the same source ID to do validation that you didn't do stuff wrong, and then you'd have your Cinder API, Cinder token, Cinder lexer token, right? So this would be the API I'd probably build for the same re-enterable lexer if I wanted to have it do token by token reading, and I can do that. I just at the time didn't. So you know what? For shits and giggles, we'll leave that there as the alternate API for the future because it is more memory efficient to do this way. Look ahead is harder to do when you're doing it token by token because you have to implement a whole look ahead buffer and stuff, yes. So doing it token by token is more complex, but it's also just a lexer and a parser. It's not the most complicated part of your compiler. So more complex in terms of like 10 extra lines of code to manage a small look ahead buffer versus more complex. It's not semantic analysis, it's not code generation, so it's not the end of the world. Do whatever gets you writing code faster. It's easy to switch between the two if you aren't stupid. Okay, so I really want to try to think of novel ways. Yeah, no problem. Novel ways that I can store the syntax tree. Normally in C, I have a Cinder like syntax kind, and then I have a typed abstract Cinder syntax kind. This will just be like our syntax node, and this will have a Cinder syntax kind, and then a union of all the things in here. Right, and this will be all of my. This is a tagged union in C. Normally, this is what I do. I'm going to have like Cinder SX invalid. So I could just do this. And I'm not opposed to just doing this because it works. But I've been trying to find other ways of having like linear syntax representations that might also not have uniform. If it's going to be linear, it has to be uniform. So this is probably what has to be. Is better if it's uniform. It's harder to make a. You wouldn't be able to flatten it. You'd still have to allocate different places, which is no fun. So if I want a flat, non-pointery syntax thing, then this has to be a uniform type, which it is here. And then I'd have to use IDs. What I've been doing is just allocating into an arena, and then the pointers are pretty local anyway. So I get most of the optimization benefit of having them in a flat array with IDs, but I get the syntactic benefit of having pointers. That falls apart when the arena has to allocate a new block, which is going to happen all the time, but like you're already going to be hitting like cache problems in the first place anyway, so an occasional memory fetch isn't the end of the world. It'll just be a slightly less local memory fetch, so it won't be as likely to be in the larger caches. So I might just stick with my ye old allocate nodes into an arena and hope the locality is fine, rather than over-engineer an entirely new syntax system. Yeah. Can you not push all the buttons on my... Thank you. I don't know which one you pushed, but it was probably like F2 or something. I'll try to type around your head. Kitty cat, kitty cat. The cable to my camera is very tight. I'm not able to move the camera down to show you the cat without like taking it off the monitor entirely and moving it under the monitor, and that would just wake her up even more. So she's just going to sleep on my function keys, and hopefully that's fine. If she gets up, you can see her. It was the button labeled self-destruct. Oh no. Okay, so let's then make syntax kinds.h if and def x sx. Nope, thank you. Define sx of id and def and undef sx, right? So now we can do yield sx of something. For example, decl function. Now, age-old question for me is, do I give a shit about splitting this up into knowing whether or not something was a declaration? So I could do sx like this, as like the catch-all, and then I could have like if and def decl define decl as id sx decl id, right? So then this becomes decl function, right? Like I can do that. I don't know if I care. It might be useful to be able to more easily query what kinds of nodes are declarations versus types versus whatever without having to write a manual switch statement to do it, or a range or whatever. So I might just do this because there's not a whole lot of downside in this case. No. Don't get your head closer to my buttons, baby. No, that's okay. Oh, that was close. She did that whole rollover with her neck, but then curled forward at the last minute and nearly put her entire body on my keyboard. So we could do like decl function, decl binding up, struct union type def is what I'm calling aliases, for example. So let's get binding and function at the top. Module is a declaration. Import is probably a declaration. Binding function. So a struct, a union, a type def, an enum. Actually, probably go right here. Struct, union, enum, type def, function, binding, import, module. That might be all the declarations we care about right now. So then we can do shit like statement, expr, type, expert, statement, decl. So like this can be our syntax kind. So if we go back into syntax, we can then say, interestingly, token kinds has its own EOF and invalid separately. I might do that with mine as well, not mine, for my syntax kinds. But we want include Cinder syntax x syntax kinds. So in this case, we just define sx id Cinder sx id, comma. So then invalid being 0 is not a bad idea, I guess. But also if I just come over here and say sx invalid as the last case, it could be the first case, I guess, but invalid can be the last case there. So this probably doesn't need to be any bigger than a uint16, so let's just do that for fun, because I have that ability. Then, so we need a Cinder range. So this will include the source ID itself, which source the range is in, and the beginning and length of it. So that's fine. The range that applies to this syntax node. Kind range. So don't know. Lucina, you are so cute, but now you have a head and a paw all over my keyboard. You're holding the F5 button. Thank you, baby. Okay. So next question, do I like struct expr, or I guess a nested union like, there's a little pop. Do we like decal statement expr type? Do we like this? Because then I can have like the group statement things. Done. And then we can have all of our things in there. I don't hate it. If I give this a name, it hates that though, right? No, it doesn't. I thought it would hate that because they're, but it probably hates this one. Yeah, because this one you can't actually access. Okay, that's funny. So if I were doing struct binding is easy enough. So this would take a Cinder syntax pointer. Now here's what we say: take this whole type def here, do that, and then just make this not a type def anymore. So then this would be type. Then we'd want initializer. Type in an initializer, bare minimum. That's what we need here. So you'd say syntax node dot decal binding type. Cool. Now I could call this declared type, because that does kind of matter. If we reuse the syntax node, what it was declared as and what it actually gets analyzed to would be different things. So going ahead and giving it a better name is probably worth doing. Declared type here. So we need to get it a name, which is probably just going to be a string view, but we want to attach it. It might even be a whole token. So if I said like Cinder token, declared name. And this might be where we like having like this be a struct instead of a union. This is fine. Declared type, declared name, and initializer. We'll need attributes here as well. So like type def struct Cinder decal attributes. That can go in here. Declared attributes. That might be sufficient. So the token here would then have to have, we haven't put anything useful in here. Cinder string view. Cinder string view. Because I'd want like a string value, constant string, for example, and like a uint 64z constant integer, and then a double constant float. And the constant string would double basically as the same thing as identifier, but we might just name it a new thing for clarity here. Float integer. This is fine. Well, we'll see if I want to rename it anything. That's fine for now, though. So we'll want to add that to the lexer. We haven't done that yet, but there's the name. A function would be similar, but it's going to have a bunch more stuff. So function is also going to have attributes. The declared type of a function, we're going to rename declared return type. Declared name. This, eventually, if we do operator overloading, will have to change from being a name token to a struct which contains potentially operator syntax information. Are you getting up or are you just getting comfy? Just getting comfy. Okay. Then instead of an initializer, this would be the body. The name is fine. So then we want an array. So there's another question. Do I want dynamic arrays in this? I don't think so. So Cinder syntax next. If we go back to this, make it a linked list. then I can say Cinder syntax parameters. We'll want to go back into our kinds here. Function parameter, for example, is a whole new thing. So like a function parameter can be a very simple thing. Linked list, yeah. This would be a function parameter, clear type name and default value. Very similar to a binding, but it's going to eventually probably have slightly different things if we do parameter semantics and stuff, but we might not. Doesn't matter, having it separate is good. So there's our function. I mean, like, unless you're talking about there's like a specific kind of linked list where it's only sometimes a linked list in some cases and it only does subsets of the entire structure, then maybe there's a name for that. It's just, there's linked lists here. So like that's a thing we can do. That is not a problem. So like our declared attributes here could say like bool is exported. Right? Is it exported? Is it... Might have... I don't think we need a static for anything. That's just the opposite of exported. I don't know if calling... Let's figure out what calling convention looks like in a second. There's our one example. Exported. There will be more. Ooh, I might want a foreign import. Got rid of the keyword foreign, but I might want a foreign import. I have so many things to think about that are probably going to happen off stream. So many design decisions. We're just kind of getting things started here. Hello. How's it going? Anyway, so like we've got this started to a point where we could probably go ahead and make a parser as well. Not that the parser is going to do anything, but we already have the parser here. So it included syntax. It's going to need a type. Not here, I guess. So type def struct Cinder parser. So this is probably also going to be re-enterable, as in it will parse an entire thing all at once. So Cinder API, Cinder parser create. So I want Cinder allocator. Should I create these within a compilation, or can they? No, because a compilation is a driver construct. So let me go look at the Lexer API and make sure I get this all in the same order here. Because then everywhere we see the word Lexer, we're just gonna parser maintain case. Cool, done. So that's gonna be the same API there. So I'm gonna have Cinder API void Cinder Cinder parser, and then Cinder source ID source. Right. So this, well, I could have a separate API here that takes Cinder tokens, right? Which might be a thing I end up doing. So the question really becomes: does a token have access? A token would have access to its source ID, so that's fine. You don't need to know what source wire you're in. So this is probably what we want as our default entry point, given the way the API currently works. So that might be all we care about. Cinder doesn't parse tokens. Just Cinder parse. Yesterday I said, for God's sake, responses. I didn't say you were rude. I mean, I did. The way you said it was rude. Not that you're rude. Just, you could probably pick better wording. Running in there, text is a very hard medium to convey what the hell you're trying to mean. So if you just randomly show up in my stream and all you say is, for God's sake, increase the font size, that doesn't come off as very not rude, is all I'm saying. Hopefully the font size is readable for you now. I did increase it before stream started, and I'm probably not making it any bigger. And if you care about the files on the left, I'll just hide them because I don't care. I don't want to increase my entire by scaling just for the font size. Cinder parse. Destroy. Okay, so that's all I need here. Let's go make a parser.c. Normally, I don't like doing all these files, but for a bigger project, I'm trying to make it easier for people to join in, read the source code. So Cinder front-end parser struct Cinder parser is going to have a lot of the same things as our lexer. If I just go be lazy, we just want these three here. I might need to grab the diagnostic engine thing for the same purpose. Include diagnostic engine. Then again, just grab the create and destroy. Nope, not that either. Lexer into parser, preserve all the stuff. Cool. Parser create, type down parser. This is just VS Code. Nothing fancy. I have it configured to be looking and feeling as little like VS Code as possible, but there's only so much you can do. The Explorer really gives it away when I have it open. If I want to be not a VS Code dev, I do have micro, so I can go Cinder lib frontend parser. Well, if I capitalize parser properly. And there we are. So I've still got micro set up in my little monochrome. Yeah, but you're also like half me anyway. Compiler for my own language called Cinder. I don't have anything solid I can point you at for what it is, and any description I give you will be vague and meaningless, but it's a C-like language that just fixes things and does things that I want. I've been making compilers as a hobby project for forever, so it's just kind of another iteration of all of my other language fun times. I am not to say that I don't have documentation in progress. Like, I'm building out a spec, but the spec is so limited. Like, the only thing in here that's useful to you is here's some keywords that I'm pretty sure I'm going to need, but it's not a final list. Like, I think we're going to re-add foreign here, then I got to reformat everything. But we'll see when I get there. So if you're genuinely curious, you can keep up with this as I update the spec. The roadmap has a little bit of information in it, but it doesn't really say much either. The example file, it looks mostly like C. If I were to like language mode to C, then most of this would highlight as C and look like C. I'm still experimenting with what characters I want and identifiers. What I want, like special library internal stuff might be using, like I might use $sign as my internal sigil. I don't know. I'm just experimenting with stuff. It'll have slices. It'll have defer. This is like a stack allocated slice so far, but I don't know if I want to keep that syntax. Very, very much do whatever C does, but change whatever I think C does wrong. There are things I think C does wrong personally that most people are so used to that I'm probably not going to change anyway, like some keyword names or some formatting. Like, I'm intentionally showing here that this syntax is fine. Most people are like, man, plus plus is stupid, so plus plus as an expression would get removed if it were me, probably, but it's so ubiquitous in C, and it's not the end of the world when it's defined properly, so I'm just going to include it and make it slightly more well-defined. Same thing with brackets around things. I'd rather everything be surrounded with brackets for control flow, but it's such a non-issue, and it's such an aesthetic thing for some people that I'm going to just allow it. And I personally will probably end up putting brackets around those things, but I'm making a point here that it's a thing. I'm allowing trailing commas in things like parameter lists because they're allowed when you're doing like designated initializers, so why couldn't we just add support for it along with the designated initializers? I don't know. It makes formatting code better, stuff like that. Obviously, C interop, I want to be able to run it with shebangs, so you can eventually, when there's a high-level standard library, you can use it as like a low-level scripting language of some kind. Module support. This example file isn't using the module support because I'm also trying to run it as a program, and programs can't be named modules, I guess. Maybe I'll change that, I don't know. But yeah, I've got lots of ideas that I just need to finally solidify. I started solidifying them in a previous version of the compiler, and I just rushed through it so fast that I was not happy with what I was doing. So we're taking it slower this time, really thinking through some decisions and compiler and the language design. I am not set on whether or not operator overloading is ever going to make it, but it's a popular request and it solves some problems. So I have an idea for how I kind of want to handle the first couple of versions of Cinder. I might be working on 2 or 3 versions simultaneously so that I can say, okay, everything that I definitely want in Cinder is slated for, like, we're going to make a version 1.0 that irons out and makes these features as good as possible. And then like a default enabled future version that can be run in parallel to test some things. So anything that's not like make or break for the language would be a 2.0 feature. And we could, as we're starting to figure out if it's more or less viable, maybe I make a 3.0 and say, okay, I'm not actually sure if this is going to work. Move it to 3.0 so that I don't have to have this concept of like nightly releases or whatever. I can still have this like in development, it's going to be a version. You don't have to worry about it being this bleeding edge thing, and move them between these first 3 initial versions to iron out what's stable, what needs more time, and what's like maybe not even going to happen. And then we can treat Cinder 1.0 as like it is this core set of features that everything else could potentially compile down to, maybe like the lowest level, low-level Cinder. So not like Cinder itself is its own IR, but it's like a lowering pass. Ideally, everything Cinder 2.0 can lower to Cinder 1.0 with minimal exception that we can, like I talk about it up here, like there's some good reasons for that. You can read this document on the Codeberg for what I'm thinking I'm going to do. So operator overloading might be a Cinder 2.0 feature, where I consider it's something you could lower down to regular function calls. And it's not a core language feature. Like you can get away without operator overloads because they're just functions with fancy syntax, right? But their existence would mean I'd have to have function overloading, which might not be a 1.0 feature either, so you'd have to lower down to manually. So like maybe Cinder 1.0 doesn't even support name mangling outside of like module names. And then Cinder 2.0 would have to manually do its name mangling to lower to 1.0 non-mangled names. Like, I mean, like there's things to consider in the high-level semantics that would make code generation easier. I'm also considering having like pragma directives so that you can control a lot of these features and compiler options at the per module level, and then serialize those into the binary file so you know what options, what compiler options a module is built with. I'm trying to get some granular behavior and really try to structure this to not be as unpleasant to deal with as some other languages. Because it's like either you wait for years and years and years to have this like perfect version 1 that everybody wants, like, or I just say, hey, version 1 is going to be totally usable, but I'm going to work on stabilizing only the easiest, lowest level, most necessary features first. And you can still use Cinder 2, but if you're looking for a stable 1.0, it'll be here. I don't know. I'm not explaining it very well, and I'm kind of rambling and cutting myself off, but like I'm working on some ideas in there. It's I don't know if I'm doing things correct. There's no correct. I'm just trying to do something that works for me and is maybe interesting and maybe useful. We'll totally take feedback, but it is so early in development that it's like you don't really have context for what you're giving feedback on either. So I'm trying to be clear in what I'm planning, but until the plan actually comes to light, I don't know that it's really going to change a whole lot from external feedback, unless it's really good external feedback, I guess. I don't know. Anyway, parser stuff. In the parser, we are Feedback, hope you won't mind. Can I just need to paste? Paste what? I mean, I'll take feedback. It just might not do anything with it. You can tell me whatever the hell you want. I can't stop you. So let's just see what the entry point for parse would look like. So parse needs to return Cinder syntax. So that's already a change I need to remember to make here. Yeah, I'm doing my best to make it readable on mobile, but I'm not watching on mobile, so I can't just see it and know. Yes, that's GCC is being a little bit too lax on the switch statement. I think I even fixed that. Why is that still showing up? Playing standards, not C, 42 in this case? 42, yeah. So I just put an unreachable there. So you're missing, if you don't see this unreachable, that should silence that on GCC. Clang doesn't care because Clang knows this is exhaustive, it'll always return. But I added the unreachable to make GCC happy. So if GCC is still not happy, then return null after the unreachable, I guess? I don't know. I mean, like, I can increase the font size even more if that's what you're telling me to do, but eventually then I can't then pull more, because it's definitely in there. The only things I've changed are this lexer and parser stuff. Everything else is up on the dev branch, which should be the only branch. But yeah, I'm streaming with a good enough bitrate. I'm at like 10K upload, 10K kilobits. So if this zoom is not enough for you and it's blurry or something, then I don't know what to tell you. The bigger I make it, the harder it's going to be for me to see what I'm doing too. I'm trying to keep it a nice balance where it's small enough that I'm comfortable programming in it and big enough that you guys can see it, but not going to just make myself unhappy writing the code for a few mobile viewers either. Not that I don't respect your mobile viewing, just I gotta prioritize what I'm doing, not what you're watching on. So let's auto root. Right. So we need some syntax creation stuff. I'm gonna try to have two editors open. This is why I don't like zooming in all that much, because now my two editors are colliding with each other. So let's make this go back to syntax.h. We should require Cinder API, Cinder syntax, Cinder syntax alloc, and this. Should we just ask for it in an arena, or should we scope these all to their own module? That might be what we do. So instead of returning a Cinder syntax, I might return a Cinder module. Then we can say Cinder typed block parser allocator, and oh, this is in totally the wrong spot, and that's why this looks weird. Cinder module pointer. So let's do Cinder module. So then we will want type construct Cinder module. Cinder module. Cinder arena. Syntax arena. So this would want to come from include Cinder core allocator and include Cinder core arena. So we can do stuff like that. Cinder syntax syntax. Hi, baby girl. You done sleeping? Am I making too much noise right next to your earballs? She's sitting up, but her eyes are still closed shut. She's still napping. Just please don't sit on my buttons. Poor girl. All you want to do is sit on my buttons. Okay. So I got no Cinder module or something. Anyway, so we can Cinder API, Cinder module create, and Cinder API void Cinder module destroy. Yield create destroy Cinder module. Then the parser can just make use of the module API. No, actually it can't. Void parse into that module. Right. Okay, that's fine. So now if we go back into parser C, this is what we want now. If parser is equal to null pointer, module equal to null pointer, then there's nothing to be done. We'll want to like set an error This should probably just be an assert, actually. I want to do some updates on how asserts work here soon. Haven't done it yet. Yeah, okay, anyway, okay, so what we have. Yo, hello, Arctic. So, syntax. Me thinking about a whole bunch of things, way too many things all at once. That's what's up. What about you? Okay, so let's make sure that we can, like, treat a syntax node as module header. Right, so I also want to be able to make sure I can parse. Any plan for Rust live stream? No, I don't like Rust. Cinder. The language is called Cinder. No, it's just regular keybinds for regular people that regular people use. I need to remember that I want a module header, so type def string. Now, we'll want to include some import statements in here at some point. So I think we don't actually want declarations here for the module stuff. Be careful, baby. Banged her head up against my keyboard. Praise be the arrow keys, yeah. Arrow keys behave exactly as arrow keys behave. If I hit the J button, it's a J button. I don't have to colon do a command. I don't have to do insert mode. Lucina, it's very hard for me to type when your face is right there. She's got her head right next to the tab and the shift and the control key. So if my pinky goes a little too close, it'll start smacking her face. There's also her whiskers around my keys. I don't want to, like, yank on her whiskers accidentally. I might have to move you, baby girl. I tickled her nose a little bit. Oh. If I can move the camera, let me see if I can get OBS to show me where. Why does it keep moving it to the other monitor? Can I pick up the camera enough? No, it's stuck. Well, you're out of luck. She's holding her face like this, and it's very cute. Poor baby. The cable is just not long enough. This one. I mean, if I control P, that's the command palette. What about control? I mean, control N gives me a blank document that I can't do anything with. That's fine. Control G is go to. Oh, control. Which one is control F? Control find. So your G instead. B for the B gives me the that. Okay. But I'm not in Emacs either. Like I can use Vim. Do I have Vim on this one? I don't. I should just have regular Vim. No, I don't have Vim on this one. Wow. Well, who needs Vim and NVim when you have micro? So, I think I built my micro from source too. If I Ccache, CMake, fossil. Yeah, I have micro from source. I think I even built my own Go compiler in order to run micro. I just don't remember. Maybe I couldn't get a build of a Go compiler to work because I don't see it in my third party there. Fourth Squirrel, PCSX, Ninja Micro. There's no Go in there. I built my own fossil. I'm not using fossil right now. I didn't build my own Git, so I had to use Git to pull a lot of. I could just use wget to pull a lot of these, I guess, but. Yeah, I built my own CMake and my own Ccache for CMake. Built my own LLVM. Clang is my own Clang. Built my own micro, so I got my own little text editor. Cool. Didn't build my own VS. I didn't want to do that. Okay, so module header. We'll have imports eventually, so we can track what modules go where. So they're not even going to be syntax nodes. So module and import, get the fuck out of there. We don't need that. Boom, they're gone. Gone. So back in parser.h then, Cinder API void, not void, Cinder module header, Cinder parse module header. I'll make this void sure so that it can go into a module. Well, I don't want to allocate a module just for dependency resolution, so I think we'll do it this way. Right, and then we can parse module unit, is what we call these. Unit tokens. Something like that's our new thing. So parser C. And then parse module unit. And then unit tokens. So then this can just Cinder module header. Not do anything just yet. Then do we want to mandate that you have to call unit header before calling parse module unit? I don't know. We'll get there when we get there. But the module unit header, instead of a string view, should probably have a Cinder token module name so that you can still get location information out of it. It's pretty good. Then, yeah, we're going to have modules here. This should probably actually be opaque. Hi, Lucina. So that's in syntax. Finally have a reason to have a source file in here. So module. So there's our module. Hello, nerd potato. Okay, so in module, we got a couple things to do. The module needs a memory allocator. Always, always, always need an allocator. So auto module is Cinder type alloc allocator module. Get that module out here. So Cinder allocator. So module is type of module allocator. Okay, so we probably want to just give it a name. Cinder string view name should just always come with a module here. Name. So Cinder arena init module arena the allocator. And we'll say I don't know, 1024 times size of Cinder syntax. Just give it 1K of syntax nodes per block. Good night. I don't know if I'll be streaming tomorrow, but if I am, sure, see you tomorrow. And syntaxes will be set to null here, that's fine. Destroy, same thing I always do with module auto allocator, module allocator, Cinder the alloc allocator. But then in this case, we also want to Cinder arena d init module syntax arena. And we've destroyed the module. So then we're going to keep this in module here and say syntax create, syntax alloc here. Let's just say auto syntax Cinder arena alloc. Aligned alloc is probably pretty good as well. Can I init? Do I have another option? No, that's fine. Alloc aligned module arena. Then it's going to be size of syntax and align of e syntax. Oh, because I called it fucking auto. Cinder syntax, that's fine. Syntax. Okay. Okay. Syntax type of syntax 0, initialize it, and give us room to fill it up with stuff. So I think we might just want to always take in Cinder syntax kind and Cinder range. Kind, range. Right? Kind and range just need to always kind of happen. Now, here is kind of a problem. I probably should not put this struct declaration in the public API. Not that it really matters because nobody can access it anyway, but I might pull it out of the public API and make it an internal thing, but for now it's fine. For now it's fine. If I were to make it a private API though, it would be in here. I would say just syntax.h, I guess. If in Cinder import syntax h. But maybe I just go ahead and do that. So I said I don't have to, but Cinder syntax here we would include syntax.h like this. Then we can grab declaration here, syntax.h, in lib, and now we have it, so this is no longer a problem. Okay. We'll get it out of the way. It'll simplify this file. We don't have to worry about forgetting to bind to it later. Because I want to have bindings for everything. I do have a project open that can do C# bindings. It's completely empty, but I want to do C# bindings to prove that the API works and give people higher level access to Cinder tooling stuff. Okay, so that's module. That's syntax alloc. Then, right, so I'll probably put Cinder module in here as well, because some things might want access to it. So then I'm going to go parser C. This now has to say include syntax. I'll put that here. Okay, that's fine. So parser needs a few things. We need Cinder tokens, size t, current position in the token stream, right? And now I get to write a bunch of parser primitives. I've been sliding down on my chair this whole time. So parser primitives here. Static inline bool Cinder parser is at end. This will be Cinder parser return return parser position greater than or equal to parser tokens count, or parser tokens items sub parser position time is equal to Cinder TKUF. Do it like that, right? So if that's the case, then we're at the end of file. It should only ever be this. So I might make that an assertion. We should always have an EOF token. Let's do that. Let's say parser not equal to null pointer. Let's say parser position less than parser tokens count. Does not count as EOF. Counts as a bug. So then we just say this. So then I'd want static inline Cinder token Cinder parser current Cinder parser, which is going to do literally the same thing, except not return that. So then this could just turn into Cinder parser current parser dot kind is equal to EOF. And since this is calling something that does the asserts, I'm not going to do it. Okay, I can just encode it like that. That's fine. So then let's say static inline Cinder token, Cinder parser peak, Cinder parser things ahead. So then we can say size t position is parser position plus ahead, which I guess should be the size t to avoid problems. So then instead of assert, we say if position is greater than or equal to parser count, then position equals that minus 1. And then, just in case I fucked up, so then is at end. Then static inline bool cinder parser at cinder parser. I don't actually, okay, so I like parser at, but I like, okay, let's not say is at end then. So if I go back into Lexer, see, we have is at end, I think. I'm just going to do the same thing for Lexer so that I can get parser at. So then we want a cinder token kind return cinder parser current parser kind is equal to kind, right? So at end is just a special case of at. So I could actually just say parser at end can return cinder parser at parser cinder tk eof. And since these are static inline, they should get inlined. We're in C23. There's no reason that it shouldn't just be a high-tech enough compiler to inline this. So parser at end, parser at, and I like parser peak at, size 3 ahead. So let me just say current instead becomes peak ahead, right? So that's good. At and peak at, we have current and peak. And yes, current could be implemented in terms of peak plus 0. That one I care less about, but you know what? Oh, double clicking. So if I then said parser current and said return, cinder parser peak at parser 0, just use AI. No, thank you. Why the hell would I do that? Then I don't care. Why the hell would I do that? I don't care. Why the hell would I do that? I do it for fun, and I don't want to touch that hellscape. Current LLM shit is a fucking nightmare. I don't want to have anything to do with. So why the hell would I use it? I don't want to touch it regardless. If I was required to do it for work, I would try to get out of that fucking job. I do not want to touch any of the LLMs. I would not, no. If I got hired to do AI stuff, I would fire myself. I don't care. Let's see, where the hell did I leave off? Yeah, he's in the timeout box because nobody likes him. You know what? So I don't have to do things. Ta-da! So now I don't have to worry about it. Now I can make you worry about it. So we need to be able to advance. That's where I'm at. Static inline. Void cinder parser advance. bool, not parser. So in this case, we just want to assert parser pointer if parser position is less than parser tokens count -1 parser position plus. And I can that's advanced. Then I like static inline bool cinder parser try cinder parser and cinder token kind if cinder parser at parser kind return true. Cinder parser advanced parser must return false. That's our try. Now I do wish I could get this as an out variable somewhere. I can, I guess. So if I said like static inline bool cinder parser try ident, then I could like, for the time being, just copy this. And then I could say cinder token out ident. And I don't have to have a kind actually, so I can just say, hey, if we're at cinder tk ident, then if out ident, if out ident, pointer, out ident is parse cinder parser current parser dot. That's just it. Whole thing. So I can actually shortcut here and say auto token equals this. And then if token kind of this here, okay, ident is equal to ident. Then we do the thing. Because I think identifiers are like the only place I really want to expect something and get its data out. So for now, that's fine. Now, parser try ident. We don't have bracket matching yet. That's something that I'll have to figure out. Do I want to do that at the parse level? So I was doing it at the lex level earlier, but it might be nicer to just have it at the parse level to track what brackets have passed through our advanced call here. Oh, sorry, baby. I spooked her. Okay, you can sleep. If I do bracket matching, it would go here. Now I need a bracket stack in the parser. So I do have the benefit of, since I'm using ASCII kinds, I can at least switch between an open and close bracket pretty easily. So I can do that with like just a stack of open brackets. So then I could say like cinder dynamic array type cinder bracket stack, and then have some kind. So then I can have a brackets, right? So then if I want a, so then yeah, let's see here. Every time we need to do a thing, auto token equals Cinder parser current parser. Then do the advanced. Then we can say if token kind is this or this, hate that, or this. Rather that one be this and this one be. Why does this language want to change fix the way we write programs? Because I have personal preferences and I want to make a language that does something that I want. Why does this language want to change fix the way we write programs? Because that's just kind of what language designers do. Because everybody agrees C sucks, everybody agrees most languages suck, so keep exploring the design space and keep having fun while doing it. It's not technically a research project, but that's what learning is. Sharing my learning to pretend it's a research project. It's just not a very formal one. How about that? It's not a good answer either, but it's an answer. Cinder dynamic array push parser birth. Hey, I know you. Brackets. Then I still got a few hours before I gotta go. That's fine. Token kind. That's fine. We like pushing brackets. Else, if let's just copy the whole thing here. If it's a closed delimiter, auto matching open is token kind -2. You want to race against a horse? Local stream in Umamusi. Okay. Where'd you get my stream as a horse? What do I want to do with this? So yeah, a lot of people recently, in the past 5 or 10 years, have been doing C, but it's what I want it to be. So I don't like explaining it that way, but that's what it is. Basically, I just like language design, and I have the most fun writing in these kind of low-level languages. And I write a lot of C. It's the only low-level language I use. So it's the one I want, the one I'm most familiar with, the one I like the most. I like how simple it is. I hate C++, don't like Rust, don't like a lot of other things. I really like simple toolchains, simple language, simple everything. Get as much power out of as little features as possible. Make it as learnable as possible. So C is just a good starting point, and it's a good language to implement it in. Preprocessor, not a great thing. Remove the preprocessor. Modules are pretty cool. My version of modules, I think, is very powerful. So do modules my way. Change the type system and declaration syntax a little bit. Stronger types, less wonky declarations. Expand the type system with slices, because slices are safer arrays. They're still not the safest. You can still write over them. I don't care, but things like that. Just fix the qualms I have with my favorite language. I still see it as a terrible language, but it's my favorite language for its simplicity. I want to have simple, usable tools. I don't want to have these giant, sprawling build systems. I don't need, like, the .NET toolchain with its XML projects and entire package registry. I don't need CMake and Ninja and whatever else. I don't need Java's Gradle, whatever. I can make a usable, simple CLI system that is better than just writing make files or raw dogging the compiler invocations, then I'm going to do that too. I just want to make something that is like C but better. It's a stupid way to say it, but that's all it is. I like the simplicity. I'm not trying to make the perfect modern language for like industry people who want all kinds of weird build steps for no good reason. This is probably going to be a language suited better to smaller teams and hobbyist programmers. So that's what I'm going for. I do want it to still be like genuinely usable. I want to have a good error model. I want to have good, like, eventually contract safety on things. I don't want to make it mandatory, but if you opt into it, then it's there. It should be a good language. I don't want people to not feel comfortable using it in a business setting if I finish it. Just that it's not the target audience right now. So we want to pop brackets. So if I can think of 3 ways to write this really ugly, so maybe I did write it really ugly first. I've got an email. Blah, blah, I need to unsubscribe from that. I hate that. Because it could be empty, in which case checking a thing would blow up. It could be the correct thing on top, or it could be the incorrect thing on top. Those are the 3 cases. There's got to be a way to fold them, but I think I just need to say if. Yeah, my problem with C++ is even if you don't write it as C-style C++, which is kind of a meme among C++ programmers anyway, is everybody on every project has their own subset of C++, their own sets of features that they like to use certain ways. Some people go very maximalist and use all the modern features they can and only opt to lower features when necessary or something. Some people stick with like C++11 and have a subset of C++11. Then you've got the people like you who are like, cool, we're going to do C until I need C++. And it's like, okay, but what things do you need from C++ that you can't just do with the preprocessor anyway? Because C++ is just like, if you do C++ 98 or whatever it is, it's kind of just like a safer preprocessor. And it gives you like function overloading. But like just use the preprocessor sparingly and correctly. Use C11 generics if you want like tiny amounts of function overloading. If you can't use C11, then sure, use C++ for that functionality, but then you can also just manually mangle your names when you need, like, I haven't been convinced by C-style C++, because it also still means you need a C++ compiler anyway, and I just prefer having a C compiler. And if I'm using C++, am I using the STL? The STL is the biggest problem with C++. Its standard library, and specifically the STL, is terrible. So, like, C-style C++, but I'm already importing all of the modern fucked up C++. Just doesn't sound fun either. I don't know. I just can't get into it. I mean, it's going to be general purpose, but I want to specifically actually have a lot of low-level functionality in it. In one experiment I did on a previous language, I had register be a declaration keyword that you could say, like, I forget what the syntax was at this point. I think it was like register, and you could give it a type like int, and so you could probably call it just like rdx, and you give it like, that's the name of the register in assembly, and then you could do, hey, cool, now you can access the register by name. I think I want to have built-in capabilities for controlling sections in the output file. So like, I don't know, this section is going to be foobar.text, and it's going to be a text section or something. I don't know exactly. Like, give you actual level control over the generated code at the object file level, and have some assembler capabilities. I don't know how I'm going to do inline assembly, because I don't want to have my own assembler parsers. So I might just do GCC style inline assembly or something, or just give you enough low-level access to things that an assembler would do for you that you don't need to use assembler for basically anything, which is why I said that register syntax might be nice. The syntax for, like, you'll have to for instructions the compiler can't emit, but I'll figure that out when I get there. I really want it to be really, really good for low-level hardware stuff, but still just a good general-purpose language. Like, it doesn't have to be good at those, just usable. Because I'd love to write an OS in this language at some point, and as little assembly as possible would be a good challenge. I could probably provide a lot of intrinsics that get by assembler instruction, which is like machine instruction restrictions. So I could provide a bunch of reserved words, built-in functionality for intrinsics that gives you low-level behavior as well. I don't have all the specifics worked out, but those are the goals. General purpose with a powerful, high-level set of features that are simple, not very extensive, not blowing things out of the water like modern stuff like C++ or C# or Rust or whatever. The Zig, we don't do Zig. but with enough low-level support to not have to touch assembly for those kind of use cases as much as possible. Again, I don't have it all formalized. Eventually I will, just don't right now. So the matching open. If parser brackets dot count is equal to 0. Cinder diagnose. So parser diags, we want to say cinder error. That's fine. But the range is token dot range. Then I mean, what do I call this? Say like %C for short, to just give the token kind as a character. But closing did not have a matching opening car matching open. How about that? Then else if parser brackets dot items sub parser brackets dot count -1 does not equal to matching open, then I kind of very interesting evaluate here. It's awesome. Yeah, language design is a whole lot of trial and error and a balance of what you want to put in versus how does it work with other things. So I'm really trying to not overload the language, but get as many of these deal breaker features as I can out of C, and as few features as I can into it to satisfy all of my desires, my requirements. Another thing I want to do is have 0 undefined behavior, which is going to be a lot of work to figure out every edge case where undefined behavior could just like show up. Not for lack of, like, it can show up accidentally just because you're not thinking about it and you didn't implement the compiler correctly to handle some case. So it just like, it's not defined in your standard and your compiler doesn't handle it correctly. So like, you don't have tests for it, you don't have expectations for what it can do. You really got to think about everything you're generating and define it in your standard and your compiler correctly, so it doesn't just mysteriously change out from underneath you, and it's tested properly and stuff like that. I'm going to make these the same error, I don't know, for now, and then just while parser brackets dot count is greater than 0 and parser dot, while that, Cinder parser brackets auto bracket equals parser brackets items parser bracket count bracket is equal to matching close break, right? Matching open rather. That's a little ugly, but I think it does the job. And good luck to you as well, I didn't say. So it'll just error on the 2 cases and then pop until it hits the correct thing. And that should be automatic bracket tracking. Then but now I don't know. No, I guess I do. Because then I can have a... I don't remember what I called it in an earlier implementation. How long have you been developing this? I've been writing compilers and virtual machines and stuff since like 2013, 2014. I forget exactly when, but around that time I switched from doing other high-level stuff to learning how these things worked. And I've had a lot of different language projects. This is like an evolution of one of my more recent ones. So this language in particular, I've only been working on for a few months, and this is me rewriting the last, like the second version of the compiler at this point. The first version I rushed through trying to get it out for something somebody else was doing to just kind of match pace with him and it didn't give me time to think about the language design or the compiler architecture. I'm just gutting it and starting from the bottom up. So this is take 2 on Cinder. This version has only been in process for a few days, basically. And it's still got a lot of ground to really be stabilized under. I'm gonna not basically not implement most of the parser for a good little while. I just want to have an entry point that can start doing things, and then I've got to go back and finish the driver entry point, the compilation structure, get the lexer up a bit more, redo the assert system, so I'm not using assert.h. Lots of things need to get done, but I'm happier with the structure, so I'm seeing if I can move forward with the structure, and so far it looks like I can. So the parser feels good. I'm not like missing anything. I'm not like cutting corners while implementing it. So in just not long here, I'm going to go back, fix all of the things I skipped over, and solidify my foundation a bit. I'm trying to make this a good public API is the one thing I really wanted to get out of the way. And to kind of force me into making a good public API, I'm going to periodically come over here into C# and build out bindings in C# for the API. And if I can have usable C# bindings, then my public API is pretty good. Lot of work, lot of work. Lot of work, a lot of work. Nick has watched me scrap so many ideas. Okay. So we've done some, so right. I think I have old, parser. I don't know. Let me just go browse through the old folder and see what I had. In compiler, because the parser, I think at this point, here, had a function. I haven't done expect yet. That's something I need to do. Advanced to delimiter end was one of the ones. Okay, so we want this advanced to delimiter end, and we wanted it as flags. Okay, so we're going to do something similar to this. I'm going to just yoink it and see what happens. So enum okay, so Cinder parser advanced to delimiter end. Cinder parser. Then bracket depth flags. So here's the problem. Bracket depth. I think I need to have a function way the hell up here. Static inline event32, which really should just be size t. Cinder parser bracket depth parser. Return parser brackets count. Parser pointer. Okay, then this becomes a size t. So then Cinder token. Maybe while I'm here, Cind goes to Cinder. Matching case. Cool. So Cinder parser at end and token. So now what we care about here is Cinder bracket depth parser is greater than or equal to the bracket depth. Then we advance. If, then again, everywhere that we have token bracket depth, Cinder parser bracket depth parser. Okay, that actually will probably just work out of the box now. I'll make it static inline. I guess this while loop is kind of like fucked. I could make these conditions a bit better, and then the inlining wouldn't suck, in my opinion, quite so much. So maybe I don't make it inline. This one could just be static. Not that the inline matters. LLVM first, then probably a C backend. I do want to have my own custom backend and my own custom IR internally, but so like doing the C backend will either entail going ahead and starting up my own IR and then having C be the easiest backend target, or just transpiling the AST trivially, which is probably a bad idea, but it might happen if I just want to get C output. LLVM first, because then I don't have to think about the backend and I can just focus on language semantics. LLVM also gives me access to the object file binaries. And part of my module system is I'm embedding, or I will be embedding, a serialized binary format of the type checked AST into a specific section of the object file. And that will be like a precompiled header for the module, so you don't have to reparse all of the module source text to get that again. And that'll eventually be nice for if I do templates as well, because I can serialize to a lower level binary form of the AST for doing expansions, stuff like that. So LLVM just gives me everything I need out of the box. While I work on writing my own wrappers, I'll have to be able to parse ELF and COFF files probably. And I'd like to not have to use the CLI for archiving and unarchiving libraries, basically. So eventually I'll have to have inline tooling for dealing with all of the object file shenanigans, right? So LLVM will keep me sane while I figure out how to do that for all the platforms I care about in the future. So that's good. So then we need expect. Static inline void Cinder parser expect Cinder parser Cinder open kind. So if not Cinder parser try parser kind, then Cinder diagnose parser diagnostics. Cinder error. Cinder parser current range. Parser, I'm going to move that a function up here as well. Static inline Cinder range. Current range Cinder parser and Cinder parser current range. I can do current kind as well, but parser current range parser. Expected C current kind. That's if kind greater than or equal to 33 and kind less than or equal to 127. I think. Then we do it this way. Like that. Okay. So then we can say static inline void Cinder expect ident Cinder parser Cinder parser expect Cinder parser Cinder ident and identifier, like that. Do I want to have these return bool? I think so. Return false, else return true. So what I could do then is actually just say if this return true, then return false is the second thing down here. Cool. I may not be no clean coder, but reducing indentation is not a terrible thing when you can. So now let's just make an example here and say if Cinder parser try parser Cinder tk module, then header dot, ooh, actually, this is where I want expect ident to Cinder token out ident, right? Because we had parser try ident. So then here, we could re-implement this just exactly the same way. So try ident out ident like that. That just simplifies that a lot. So then we can say down here, if not Cinder parser expect ident parser header module name, then Cinder advance to delimiter end parser Cinder bracket depth parser and Cinder semi, right? Cinder parser expect. Let's say expect semi is a new function we want. So going to the delimiter end, we advance. Oh, we do still want to get the token though. So let's say token Cinder parser current parser. Then do the thing. I forgot about that. That is a good thing. Then we've already advanced past the semicolon, if that's the case. So yeah, so then expect semi can go static inline equal Cinder parser expect semi Cinder parser return Cinder parser expect parser semicolon like that, because that's a common one. So then that's a quick module header parser that doesn't handle imports. Does it build a line of applied to an expression as a GNU extension? Well, yes. So I have to enable GNU extensions to do that. That's fair. So compiler.h, I think, is where I put that for a line of E. So if I say just if it's GCC, not if it's Clang. Okay. Git status, git add, Cinder, git status, git add. That's fine. Init, start playing out the syntax. Because I need to go eat something and get ready for birthday cake at my mom's house. So I'm going to call it here. Thanks for stopping by and chatting. Except for that one guy we got rid of. I'm having fun again. I do have a Discord for this language. If you're curious, it's in the bio, but I can paste the invite link here if I go find one. The repository for this is on Codeberg. That's also in the bio, but I can share that as well. Let me just go find where the hell these are. I need to keep these on hand, don't I? If anybody cares, I occasionally talk in here. I need to use this Discord more often. I'm trying to. There's just nobody there to talk to, so I don't use it all that much. And https /s codeberg.org cinder for the project. I'm keeping it synced up a bit more. If anybody does want to contribute, not that I'm accepting much right now, but if there's something obvious, there's instructions in here. You can do code pull requests, but I do actually have a mailing list. Not that I do anything with it yet, but I'm trying to set one up. You can send patches with the modern git patch stuff to patch@cinderlang.org, and I will apply it. There's instructions on how to do that. This is the format that's accepted, basically. That's what I'm prepared to do. Very minimal build instructions because it should just build. If it doesn't, that's the kind of thing you could definitely send patches for is, hey, it doesn't build on my machine, but I figured out why. Definitely give me a patch for that because I only have 2 setups right now. A half-broken Windows setup and my super simple Linux Mint on a modern Clang. But thanks for stopping by. I'm gonna go eat some food and fill up my water. Goodbye and all that.